We're going to try another inequality. It's going to be the inequality 2x minus y is greater than 8. Now remember, before we graph the inequality, we've got to graph the equation. The equation 2y minus 8, 2x minus y equals 8. That equation, the graph of it is a line, and that line is the boundary between the solutions and the non-solutions. Okay. When I graph the line, remember my go-to method for graphing these is to use the x-intercept and the y-intercept. But again, you could use any technique, t-table or xy table. You could solve for y and use the slope-intercept form, whatever works for you. I like the x and y intercepts. So with the x-intercept, the y value is 0. You end up with 2x equals 8. Divide out the 2 and x equals 4. So 4, 0 is on the graph. For the y-intercept, the x value is 0. So you get negative y equals 8. Divide out the negative 1, you get negative 8. So 0 comma negative 8 is on the graph. Okay. Now, one thing to keep in mind before I start to graph this is that this inequality is a strict inequality. It means it's just greater than. It doesn't have the equal sign. And in those cases, the boundary, which is this equation, is not actually part of the graph. So we're going to leave the line itself dashed. Okay? So line is dashed. We've got to keep that in mind as we plot this. If you're doing this in pencil, it's no big deal. If you mess it up, you can always go back and erase what you need. But if you're doing this in pen, or I am in marker pen, you're really not going to want to make a mistake on this. Okay, so let's plot this out. I don't know how far down I need to go here. In fact, I may have moved that too far to the right, but that's okay. We'll make it work. That's probably good. I know that 4 is the x-intercept, so 1, 2, 3, 4. I know that negative 8 is the y, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's that spot. Maybe I'll go down a couple more just to make sure I've got enough space here to graph this out well. Alright, so now remember it's going to be dashed. Almost made the mistake here. I was just kind of cruising, so remember it's going to be dashed. So I'm going to want just putting a few points in here so I'm not missing anything as I plot this. Getting a little close. Okay, so again, dashed line. So we're going to start down here, and we're going to dash that in. Okay, so I've created a dashed line. That means my boundary is not included in the solution, but the solution is going to be on one side or the other. Now remember, we use what I call a test point. And with a test point, I'm going to choose the point 0, 0, again because the original line here is not going through 0, 0. And 0, 0 is just a nice set of numbers for arithmetic. So when I plug those in, 2 times 0 minus 0 is, of course, 0. And 0 is not greater than 8, right? But plug that in, definitely not going to work. So the side with 0, 0 is going to be not the solution side. Not a solution. Okay? So I don't want to shade this side. That means I must have to shade the opposite side. So we're going to shade in the side opposite. There, close enough. We got to shade in the side opposite the origin. So any point in this region then, to the bottom right, is going to be a solution. If you pick a point, and I'll just give you an example here. Let's take this one right here. That point is at 1, 2, 3, comma 1, 2, 3, 4, 5. Let's take 3, 5 just as an example. Okay. 3, comma 5. If I plug those in, you get 2 times 3 minus 5, right? Oh, I'm sorry, that's negative 5, isn't it? That was a negative 5. So it'd be 2 times 3 minus negative 5. That's a double negative there. And so when you test that, 2 times 3 is 6. Double negative makes a plus. 6 plus 5 is 11. 11 is greater than 8, so that one checks out. And in fact, every point on this bottom right region will make the left side of the original inequality greater than 8.